So I'll go ahead and get started. This is what I talked about when I was on the panel. So this is an example of a simple, the most minimal test station you might have if you wanted to run some of our automated tests. So what you have is a router, which is that guy in the middle. It's actually a D-Link DGL 5500 router. 3 Raspberry Pis. So one of them is acting as a WAN machine, one of them is acting as a LAN machine, and one of them probably wireless. Or actually, it might be a control machine. But in addition to that, you have a network power reset. So the test framework will connect to these machines. It'll start typing commands and executing tests. And you can basically, anything you can do by SSHing into these machines, you can do in the test framework. This is a picture of our lab in Austin. We have 2 of these now, actually, with 24 boards in a rack-like setup. We actually don't use Raspberry Pis as our test devices. We actually have a VM, a nice big server with a lot of Ethernet ports running VMs. So we have like 2 servers that will actually drive all these, I shouldn't use the word stations, drive all these routers to be tested. We also have done things with like USBs on these VMs as well, USB Wi-Fi, so we can actually do Wi-Fi testing, functional testing at least. We also have some logging features. We log to Kibana. You just type in a place to dump your data, and you'll start logging. All of our tests can store or can submit results. So one of our tests is iPerf bidirectional throughput. So this is an example of wired tests. You can see different. There's actually I should point here. There's some different board types, and you can see the performance trends on a day-to-day basis. So this kind of goes along with our continuous integration test and build process. So we can go back and look and see this day our performance went down. We know what changes went in that day. We can do more debugging from there. This is an overview of the board farm, like everything that ran. So we have different board types. These are all internal board names. So I don't really know how to translate that. We actually have these racks set up at 3 different sites, one in Chennai, San Jose, and Austin. We're trying to get one external facing the internet so we could maybe set up some sort of automated regression on images that OpenWrt produces on a nightly basis and send emails to the developer list. So I think this is the one Kathy decided to add. So that's pretty much it, though. If there are any questions, talk to me now or later. I didn't do any of that. I don't even know what half those are. So.
So Linux is a rather crufty ATM over TCP, which pretty much gives you a good DSLAM or run-of-the-mill DSLAM. And then if you dig around the WPA supplement code, if I remember, or is it host AP? I can't remember. They've got a nice little Python test suite that simulates every wireless network. So you get an AP, and then you have a client on 2 separate interfaces, and then link them together and fake SSIDs and connect to them.
So a lot of this was checking for regressions and performance, namely. It seems to be important for us. So we had to use real hardware for a lot of the things. But that's definitely a way to make it cheaper. Like I've thought about, I haven't actually done, but you can do QEMU images and do the same sort of test infrastructure. You could use VirtualBox and do it on x86. You could have kind of virtual test stations, and you don't even need a rack really, right? But the current set of tests we have aren't that comprehensive. The tests we have so far are born out of developers needing to do dev tests. So like when I do a feature, I go and make a test for it first. I don't have to type it every time. So I literally just I just use the up arrow and hit enter, and it flashes my image again, finds a free board, runs my test, and then I know if it's working or not, and I go from there. And we also have regressions, so we use this in our continuous integration. So it tends to not be quite as comprehensive, so we don't test all of Wi-Fi and all of its features yet. We don't have tests to do that yet. It's not as comprehensive as, say, CD router, but we have our QA teams actually going to start adding tests to this. It's been an uphill battle. This is born out of the developers actually wanting something to use, not the QA side doing their own thing. So.
But I would recommend, if you're interested in wireless testing, Yoni Malinan, who's our guru of all things host ABD and WPA they're going to host a wireless summit at the NetDev conference, which is on this page. If you go to netdevconf.org, the second round of this, and our upstream wireless team and Kale, Valo, Yoni, they'll be at this conference.
And one of the big things too is it's not necessarily even the test framework itself, it's just a common way to define a setup. So like we use this to bootstrap other tests as well. So
For me, it was just like, I've got my fake ISPs, it's still connecting, can it do P6, just same sort of thing, it was quick,
yeah.
it works.
Yeah, that's the idea. So if there's any other questions, feel free to get in touch with me later on. And all right, I'm done.
Thank you very much.
All right, hello, I'm Jonathan Bennett, looking at Fwknop, Luci, and QR codes, a lesson in usability. So, first off, what is Fwknop? We probably know what Luci is, being here all together, and I'm assuming most of you know what a QR code is. Fwknop, it was written by Michael Rash and Damian Stewart. It's an implementation of something called Single Packet Authorization, SPA, which I'm sure tells you a lot. So what is SPA? It is a replacement for port knocking, but it actually gets cryptography right. Port knocking was really security through obscurity. Once an attacker knew what the trick was to get into the SSH port or whatever you were protecting, the security was gone. So you had replay attacks, you have denial of service attacks, man-in-the-middle attacks. It was all trivial for the old school port knocking. SPA uses proven crypto, HMAC, AES. It provides really good security. SPA has many applications. The most common is to protect SSH behind a default drop firewall. Now you might ask, why do we need to protect SSH? Because there are people like Robert Graham that have come up with a way to scan the entire IPv4 network, the whole internet for port 22, and he can do it in about 5 minutes. So, a user authenticates by sending a single UDP packet. It contains a SPA message. I think that Fwknop is a great fit for OpenWrt. And there's a couple of reasons. First, OpenWrt tends to be a public-facing device. It's your router. Fwknop works by capturing packets that the firewall would drop. It uses PCAP. And then it manipulates the firewall when a legitimate user has authenticated. It runs on the gateway. Therefore, it allows us to do fun things like port forwarding to an internal machine instead of just connecting to SSH on the router, because really that's not that interesting. You authenticate, then you can SSH directly to your desktop if you want to, if it's running that away. Also, Fwknop has very small binaries. I can fit Fwknop and my Luci app on a $20 4 meg router. Fwknop has been available on OpenWrt for a very long time, but it was hard to use. Seeing the potential, and by the way, I maintain the Fwknop package I have for a while now. Seeing the potential, I wrote a UCI layer and a Luci interface. It looked like this. It worked, and I thought, well, my reason for doing this is I wanted it to be useful for me. This is kind of the idea that drove my development process. I was not using Fwknop. I wanted to. I also want this to be useful for a normal user. Most people don't want to have to log into their command line on their router and mess with config files. So I try to use same defaults, make it so that you set it up, it's good to go within 5-10 minutes. You don't have to spend an hour reading the manual. Now I can use it. Maybe. So I thought through this. The Fwknop client is on my desktop. The Fwknop daemon is on my router, which is also my home network. So that means if I'm outside my network, where I'm going to be using this, I'm not at my desktop, which is where the client is. There's a problem. It's not useful yet. So, Android client. I take my Android phone with me everywhere, and there is an old Fwknop client that existed. It had some flaws, was no longer maintained, so I rewrote that and made it useful for me. I quickly decided I did not want to type super long SPA keys on my Android phone on the touchscreen. It's not any fun. Came up with something though. Just about every Android device that we have has a camera on it. So the solution is put a QR code in the Luci interface. So when you install, the keys are generated, the QR code is generated. You pull the Android app up, you put in the IP address, you hold it up, it goes beep, and it's done. It imports the keys. You're then good to go. This is the most useful interface that I can imagine that doesn't either restrict or kind of insult the user by limiting what he can do with it. It is now usable. It is in OpenWrt 15.05. Everything's in place. You just have to go grab the package. It installs. You're good to go. We're already looking into the future. Michael Rash and I are in the process of writing a single packet authorization, RFC. We're looking forward to getting that done and published. I'm also working on something interesting, a web page that instead of serving your IP just in text form, it'll give you a QR code that has your IP in it. This works so that you would be able to use the Android app to authenticate a desktop, even when your Android is still out on the cell network. You can let your desktop get into something. An iPhone app is planned. It'll be official. It'll be available on the App Store. It's coming sometime, eventually. And then for more information, come talk to me tonight, today, whatever. Answer any questions that I have. My email address, the primary Fwknop website is here. At that website, there is a tutorial that just has loads and loads of information, all that you would want. And then the website where I have put all of this work is here, incomsystems.biz/fwknop-GUI. Thank you very much.
Hi, everybody. I just wanted to talk briefly about this new initiative that I'm working on. It's called NetJason. I talked about it at the Battle Mesh, so I'll try to do a quick overview because we don't have time. So it's a data interchange format designed for networking software, which is based on JSON. Stuff like it's designed for software like dynamic routing protocols, network databases, monitoring tools, and firmwares like OpenWrt. And for community networks, but also municipal Wi-Fi and ISPs. Let's see. Okay, so one of the objects is network graph, and another one is device configuration. That is maybe not surely the most relevant to this summit. So it was inspired by GeoJSON. Maybe you know a little bit of it. This is a GeoJSON object, and it's really cool because you can use it to make software interoperate, written in different languages, but they still can understand. One library in C can understand another library written in a different language. So, for example, this is a GeoJSON displayed automatically on GitHub. You can try to do it yourself. And so it's very powerful. Having a standard is really powerful. So basically, developing software for heterogeneous networks will make you feel like this guy here. And because interoperability is like very not taken care enough. So let's skip to directly what we can do with stuff like this. So if we have a common graph format, we can make a visualizer that can show a network topology with any routing protocol. But okay, so actually I haven't shown anything. Let's jump directly to the website. If you type netjason.org, there is the RFC, which is currently a draft. It's not submitted yet. We are still improving it, but we want to do it soon. Then there is the GitHub, where you can find quite some information. And I show you the device configuration object, one of the examples, which is relevant to OpenWrt. And the format has been inspired by UBus, by the way. I also have been trying to get feedback from some OpenWrt developers on IRC and a lot of people in the community network stuff. So you can see there is there are information about general information, hardware information, resources, but the total amount of resources available, the radio settings, the interfaces, the wireless configuration, the addresses. It's very similar to UBus, but it's different in some way, so that we put some effort to do it in a way that is readable and stuff like that. So we have a few implementations already, and there's one which is pretty relevant to OpenWrt that we plan to use in OpenWSP. Show you something really quickly, and then I'm done. So here it is, this small Python library, which I'm working on right now, which converts NetJason to UCI, basically. Here you see an example. So very simple, a very small object, which has a few, one Ethernet interface, which has 3 IP addresses, and one of them is IPv6. When converted, becomes this thing. So I've wrote a long explanation of why I think this is a good idea. So if you want to look it up, look about, maybe if you look about NetJason config, it will come up. So you, no, I mistyped. No? Come on. Let's see if it comes up. Okay, here it is. Okay, here is quite a long explanation about the problems that I actually face at work. And so if you're interested in it, read it, send us feedback, and thank you.
Hi everyone, I promise technical one. So hi everyone, I promise I won't keep you for long from the evening drinks. My name is Zoltan Herpai, and I'm the maintainer for 2 targets in OpenWrt. I'm going to give you a 10,000 feet view of the sunxi target. This one is for my employer. Thank you. A moment. Right, so the target is about supporting the all-winner SoCs. These are ARM chips, which come in various flavors: single core, dual core, quad core, and even 8-core chips. These range in the 1 to 1.5 gigahertz lineup, so you got a pretty good amount of processing power. These first appeared in Chinese tablets a couple of years ago, and then went on to various dev boards when manufacturers picked it up. The target was committed into trunk in 2013, around 2013, and now it got released into the Chaos Calmer release. So peripherals, you got a lot more than your average router has. Most dev boards have 2 or more USB ports, various connectivity. It got I2C, some even has audio, and most of them have HDMI connections as well. So the HDMI output is right now starting to get supported in the mainline kernel as well. Usually the dev boards boot off an SD card with U-boot, but there is also work to support booting out booting from the internal NAND chip. And also, because we are talking about IoT, we also have to mention that the boards also feature a lot of GPIOs usually. So what can you do with it actually? You can do a Stratum 1 NTP server, either from GPS or from the Edinburgh 1 o'clock gun. You can listen to airplanes, and you can also do a machine gun for your garden if you got a lot of these. Thanks, Mr. Burkus, for the idea. I've listed some of the manufacturers where you can buy these boards from. Unfortunately, the own mailbox one, which was providing rather a service as to just the board, just went belly up. They didn't get through the Kickstarter process, but hopefully they will try again. There are some manufacturers as well that if you want to just kickstart your project, they are also providing downloadable CAD files. So you can just download it, build your own board, and just solder it on if you want it. So all in all, with this target and with these boards, you will get a lot of processing power. So you can do Node.js, or you can do your home automation if you'd like. and usually at a rather low price point. What can you do if you want to help? So there are lots and lots of dev boards right now, and more are coming. So please test the features. Although the code base is usually common for these ones, but still there are subtle differences in the DTS files. So please test them out as well. And if you see a new one, please send DTS as well. The near future plans include setting up the NAND boot, because right now these are obviously booting out from an SD card, and also OpenWrt is rolling out new SoCs as well, including the H3, H8, and they're also trying the H64, which is a 64-bit ARM core, and we also gonna need patches for that. So that was a quick one. Any questions? Yep.
How much power?
How much power do they draw? So my best recollection is that the dual-core version takes about 2 watts, but you also got CPU throttling available, so it can go down like to 1 watt. This is the A20 SoC, which is. 1 watt is the lowest, yes, as far as I know. You can? Okay. Okay. All right. Okay. Okay. Okay.
Do they have a native Ethernet or Wi-Fi for both?
No. So the Wi-Fi is usually wired in via USB. And so sorry, there are some cases when it's wired in via the SDI via SDIO, but it's not native. Thank you.
So, hi, I'm Burt. I want to talk about the kernel in OpenWrt. I think there's kind of a problem there. The first problem, and this has come up before today, is well, subversion. The fact that it's still in subversion is a major problem, but it's not the only problem. But to start with that, it's, for example, very difficult, or let's say a lot of work for OpenWrt to switch to a new mainline kernel. Why? Because, well, the patches are kept as patch files in subversion. And that's, that may have worked 15 years ago, but that's just really not really optimal today. They should just be in a Git repository. It should just be a branch off the mainline. But the other problem with kernel maintenance in OpenWrt is the fact that, notwithstanding that OpenWrt, I saw some slides today where forks should be upstreaming and OpenWrt upstreams and this and that, but actually kernel patches don't really tend to get upstreamed to mainline from OpenWrt. Specifically, well, it's not really for everything. Like the switching framework in OpenWrt, there's no room for that in mainline. There's another one now called SwitchDev, but the drivers, OpenWrt has support for a whole bunch of chips and then different drivers. But like, for example, switching chips from Qualcomm and whatever. And those have never been mainlined, and that's kind of a problem. It causes a problem because not only does that code in OpenWrt tend to bit rot, simply because it just doesn't have the maintenance that the mainline kernel gets, but also it tends to use internal kernel interfaces and APIs that are just deprecated in mainline, and that just and never get deprecated in OpenWrt, and that just creates more work whenever OpenWrt needs to switch to a new kernel. I think that's a major problem because OpenWrt does not switch kernels or switch mainline branches often enough. I see that Chaos Commer is now on 3.18. That's nearly a year old. It is forked off of a long-term stable branch, and that's good, but long-term stable branches are good for 2 years. They get patches, like security patches, for 2 years, then it's done. But OpenWrt gear, as somebody else here said today, tends to easily run for 5 years without much in the way of changes. You need to be able to upgrade that. The only way to really properly keep that kernel up to date is to keep up with mainline. So what I think needs to happen is that OpenWrt needs to basically upstream all its kernel patches, except, of course, the switching stuff, which in fact should be replaced by the kernel switch dev framework. This needs to happen anyway. So I've had a first look at this. I've mainline one driver from OpenWrt. I saw all of that bitrot of a lot of code, just obsolete interfaces that you wouldn't get into mainline now. You just need to upgrade to the new interfaces, or your code just not going to get in. But I also saw a bunch of dead code, for example, like 40–50% of that particular driver was dead code, was not called. That would never wash in mainline, and that's a good thing. That's what you want. So the whole thing was really not a great experience, I must say. You had subversion to struggle with, and the fairly elaborate target structure, which is really not necessary because it's just supposed to be kernel code in the kernel file system structure. But also, it was just I don't know, and what I saw also was very little interest from OpenWrt core developers. I contacted a few, but I saw very little real interest in I was expecting something like, you're going to mainline some drivers. If I was, that's good, less maintenance work for us. I didn't really see that. So I'm kind of wondering, I'm going to, the driver that I mainlined was for a board that I have. I'm going to mainline the rest of the drivers that board needs so that I can have the entire board running on a mainline kernel. And there's a few drivers left to be done. I think all of them should be done. But what I'm wondering is, am I alone in this? Am I alone in being interested in this and being willing to put in the work? So I'm going to be at the social event later. If you're into that sort of thing, if you think there should be some change and some work should be done, do come and talk to me, and we'll see if we can maybe do this in a little bit more structured way. So thank you.
Okay, hi everyone. I have actually purposefully started with the last slide because I wanted to say thanks to OpenWrt for helping us over the last 3 years, even though we've been hiding in a room in West London somewhere. So thank you very much. So yeah, indeed, why am I here? My name's Simon, and I am the founder and big chief of Cucumber Tony. So Cucumber Tony is essentially a Wi-Fi platform for resellers and distributors to use. We've got about 2,500 boxes, and we have recently been called the poor man's Meraki, which I'll quite happily take.
Where is that?
Huh?
Where is that?
Whitstable, no? Whitstable. It's good. It's a lovely place. I was very happy that day. So yeah, for 7 years after university, I was kind of setting up hotspots. I didn't really know what was going on. Then I started spending like $600–700 getting boxes that I could cloud manage. Thought this was a little bit unfair. Figured out that Wi-Fi was clearly quite important to everyone. So decided one day with 2 or 3 other nerds that actually, why didn't we try and manage all of these boxes around the world ourselves? So I said do it, and I said it couldn't be that difficult, and how wrong we were. So it has literally been 18 months, I guess, now of misery building this platform. So the idea was that we would take these OpenWrt boxes that we didn't actually understand what OpenWrt was. We didn't really know what firmware was. I couldn't even particularly write code at the time. I didn't. So we started with Ruby, which is also a poor idea. And yeah, we set off. We had kind of templates on a server. We wanted like stateless boxes so we could send stuff down to them. We had VPN connections. We ended up doing like a load balancing VPN service and then a remote reverse SSH connection to get config files down. Then we had like boxes going out of sync, disappearing off, and customers angry in South Africa. So it was generally 18 months of misery. And during this, we realized that the internet is one mean thing. So whatever can happen did happen. So we even recently got struck by lightning 4 times when Google's data center got taken out. So we've definitely planned for the worst. But coming out of this, we've invented what we've called Socketman, which is nearly open source, and it will be open source at some point. It's a little C client that runs on OpenWrt. There's no modifications to OpenWrt whatsoever, and it basically just listens. So it creates an MQTT connection back to some servers that we've got, and then we have some bizarre configurations. And actually, what I found out today, and I didn't realize this, from hiding in an office for 3 years, that we've basically been through the same challenge as you and the same challenge as you, but we just didn't have any idea that we were doing this. And we were talking about this on the plane, like, have we been ridiculous? We had no concept about what we've actually done. So it's been good to hear other people's stories. So this is actually what one of our network files looks like now. So because we couldn't test it, and I didn't actually realize this was a problem in OpenWrt, we didn't realize this, we figured we couldn't test it. So we decided that a network file for us should look like this. So it's one line of code. And then on the other side of things, we build the network files line by line by line by line, which means that each line of our networking files, wireless files, DHCP files, DNS mask files, whatever it is, can be tested. And I think it was about 6 months ago that one of the other chaps in the office said, have you ever heard of SDN, Simon? And I mean, literally, we've kind of invented this software-defined service, but I had no concept, again, of the fact that that existed. So yeah, now we've got about 2,500 access points, 30,000 clients a day. We've got an analytics service, which is actually open source, that processes about 1 billion data points every month. And the nice thing about it is that a box in the middle of nowhere, you can send a job to it in 3 seconds, or less than 3 seconds. So there's no particular need to worry about updates. All the updates are done server-side. So we can test them through a kind of minor changes in firmware releases that we have, so just a number. So we can push different releases to different boxes at different times. You can first boot a box and it'll reboot and reinstall itself and come back online. So far, so good. But, I mean, I think that's actually me. That's done.